change the variable. Change the variable is a technique when all else fails. For example, what are you going to let u equal to in this first one? X squared minus 1. So du is 2x dx. Do you have at least the x? I do. So I want to put the 2 here, and I can do that if we had 2 over 2 and we pulled that 2 in. So this is the same as 1/2 u to the 1/2. This whole thing is du. So what is the antiderivative of u to the 1/2? It's u to the 3/2 times 2/3 of u, x squared minus 1 plus c. All right, so the whole thing will be 1/3 x squared minus 1 to the 3/2 plus c. So this one works. But what happens when you let u equal to x minus 1? Does du work? No, you get this extra x, and this doesn't work. So you think. We're going to use a new technique that you can actually do it. If it doesn't work for u sub, you're going to be able to do this. And I think you're going to really, really like these. Let's go back, this example here. Would you just do this with me? Just write right on your iPad, x square root of x plus 2 dx. And how we're going to do this is we're going to let u be equal to this inside thing, x plus 2. U equal to x plus 2. What is x equal to then? U minus 2. That's nice to know. What's dx equal to? 1 du, yep. You okay with that? Now we have everything we need to change the variable from x to u. X is no longer x. X is going to be what? U minus 2. Has nothing to do with the band. And then it's going to be x plus 2. Well, that's u to the 1/2. And what's dx? du. Now you're kind of going, so that looks horrible. But actually, it's not, because now what we can do is we can multiply u times u to the 1/2 minus 2 times u to the 1/2 du, and you can take the antiderivative of each one. Let's simplify it first. U to the 3/2 minus 2u to the 1/2. And so what's the antiderivative of u to the 3/2? U to the 5/2 times 2/5 minus 2 times u to the, raise the power, 3/2 times 2/3. And what was u again? I got to remember. X plus 2. That is the antiderivative of that. Do you believe me? If you don't, what could you do? Yeah, take the derivative of this, and if you took the derivative of that, it should simplify to that. But we're not going to do that. Is that okay? Go on to the only problems that I'm assigning, which is 1AB and Challenger D. Those three. We're going to do A together. No, let's not do A, because we already did an example like A. You can do A on your own. Let's do B. B is better. B is better. Take x squared, square root of x plus 1. What do you want u to be? Let's go for it. Yep. By the way, there is a group of people that feel that, and teachers, that you should let u equal to the square root of x plus 1. It actually works. It's just a different way. I prefer this. Students catch on to this quicker. X is going to be u minus 1. So what is dx going to be? Du again. That doesn't always happen, but it did in both of these cases. So now we're going to plug in x squared is going to be u minus 1 squared. This is going to be u to the 1/2 again. Dx is du. Do you see why this one's a little more work? Yeah, you got to expand this thing. This is u squared minus 2u plus 1 times u to the 1/2. It's just a little extra work. So then it's just going to be u squared times u to the 1/2 minus 2u times u to the 1/2 plus 1 times u to the 1/2 du. And I'm doing an extra step than you probably need to. So this is u to the 2nd half. What's that, 3/2 or 5/2? U squared times u to the 1/2. 5/2 or 3/2? 4/2 plus 1/2. Then the next one's going to be minus 2u to the 2/2 plus 1/2 is 3/2. U to the 1/2. And now we're ready to do the final. This is going to be u to the 7/2 times 2/7 minus 2 times, let's see, raise that, 5/2, 2/5 times u to the 5/2. Ugh, this is not looking good at all. I'm just going to go this way. U to the 7/2 times 2/7. What was that, x? Was that x plus 3? What was that, x plus 1? And then it'll be minus 2 times u to the 5/2 times 2/5, x plus 1. And then the last thing will be u to the 3/2 times 2/3, x plus 1 plus c. There's your answer. Have a great weekend. Just do those two, number 1A and then that D.